section 3.1, quadratics. This is part 1. And we're going to start with looking at a function f of x equals 2. Well, what kind of function is that? Well, if I look at it, if I graphed it, it would be a horizontal line crossing 2 on the y-axis. And so we call, because it's a straight line, it's horizontal to the x-axis, we call this a constant function. And we say it has degree 0. And it has degree 0 because there are no x's, and if there was an x, it would have to have an exponent of 0, because x to the 0 is 1, which means 2 times 1 would just be 2. So our degree is 0, and the leading coefficient, well, we only have one coefficient, and it is 2. The next one we look at is 3x minus 1. f of x equals 3x minus 1. And we call this a linear function because if we graphed it, it would make a line. And it has degree 1 because the highest exponent in this problem is x to the first. And the leading coefficient is a 3. The next one we have is f of x equals 4x squared minus x minus 1 plus 1. Okay, now this has an x squared in it, which makes it a quadratic, which is what we're going to be concentrating on today. And we say the degree is 2 because the highest exponent in this whole thing is 2. We don't add the 2 and the 1 and make 3. We just take the highest one to get the degree. And the leading coefficient, that means the coefficient in front of the highest exponent. Well, this x squared is the highest exponent, so my leading coefficient is 4. The next one says f of x equals 2x cubed minus 0.5x plus 5. And this is called a cubic function. The degree is the highest exponent, which is 3. And the leading coefficient is the number that's in front of it, highest exponent. The leading coefficient is 2. And the last one here is f of x equals negative 3x squared plus 5x cubed. Again, the highest exponent is a 3. And so we call this a cubic. And we say the degree is the highest exponent, which is 3. And the leading coefficient is going to be the 5 because it's in front of the x cubed. Now, one of these we're going to concentrate on today is this one right here, the quadratic equation. We've done some linear where we've graphed lines, and a constant is a straight line. Cubics, we've done just a tiny bit on that, and we're not focusing on that today. What we're focusing on is quadratics. So I'm going to erase this, and let's talk about a quadratic. Quadratics most of the time look like this: ax squared plus bx plus c equals 0. Notice the highest exponent is a 2, and the leading coefficient is a. And it typically looks like this. Now sometimes it could just be ax squared plus c because the b would be a 0 and that would be gone. But you always, the a cannot be 0. The a has to be a number that when you multiply by x squared, it won't eliminate it. So this is a quadratic. Another way to write a quadratic is in this form: a x minus h squared plus k equals 0. When you can write it like that, then you know the vertex of the quadratic. H comma k is the vertex. So what is the vertex? Well, whether I draw a quadratic like this or like this when I graph them, this top point or this bottom point, those are both vertices. This one is a minimum and this is a maximum, but it is the highest point here and the lowest point here. All right, another thing we know, if we can get it into this form right here, which would give us more information than just this one, then we know if A is greater than 0, no matter if it's in this form or this form, we know that the graph is going to open up. If the A is less than 0, that means it's negative. It's going to open down. If you take the absolute value of A, and it's bigger than 1, that means it's not a little fraction, it's bigger than 1, then we're going to have what we call a vertical stretch, which in other terms means it's going to be closer, skinnier, typically closer to the y-axis, but it depends where it's located. But it's going to be a skinnier parabola. If my absolute value of A is less than 1 and greater than 0, that means it's a fraction in between 0 and 1, then we call it the vertical shrink, which means it kind of lays flatter, typically closer to the x-axis. The outside lines out here just kind of lay down flatter to the ground. Okay, so we also can tell something else. This is an HK, and we said this is our vertex. But another thing we know about it is, if it says minus H here, and it's within this being squared, okay? If that happens, then we know the graph is moving to the right. Or if this were x plus h, again, it moves opposite. It's going to move to the left. So we could graph just a simple ax squared, and then we could shift it. We could shift it left or right if there's some other number in here besides just x squared. So if our h is a positive number, that means that would be x minus a positive number. It's going to move to the right. Shift our graph to the right. And if our h is less than 0, then this becomes a negative number, and x minus a negative would make it x plus h. That means it's going to move to the left. We can all tell something about the k. Whatever you tag along here, if the k is bigger than 0, you're going to move it up. And if the k is negative, we're going to move down. Okay, so I'm going to erase this, and we're going to graph using this information. Okay, so let's look at x squared plus 4x minus 4. Okay, so we don't have it in that form of a parentheses x minus h parentheses squared plus k. So we only have this form. So once we have this form, all we can tell is the number in front of the x squared, which is a 1, it's positive, so we know it's going to be a graph looking like that. We don't know where it's going to be, but we know it's going to open up. So let's make a table here, and let's see if we can figure out uh, what our f of x is going to be. We'll make this f of x right here. All right, so if I put 0 in for x, that's 0 squared plus 4 times 0, all that's 0, minus 4, I get negative 4. If I put 1 in here, 1 squared is 1, plus 4 times 1 is 4, 1 plus 4 is 5, minus 4 is 1. Now we need more than 2 points because this is not a line. We know it's a parabola and we know it opens up. If I put negative 1 in, negative 1 squared is 1. 4 times negative 1 is negative 4. 1 and negative 4 is negative 3. Minus 4 is negative 7. If I put 2 in, 2 squared is 4, plus 4 times 2 is 8. So 4 plus 8 is 12, minus 4 is 8. Oh, I'm sorry. Yes, 2, 8. All right, let's try negative 2. If I put negative 2 in here, I get 4 minus 8, which is negative 4, minus 4 is negative 8. All right, let's just kind of see what that looks like already. See if it's beginning to take form. 0, negative 4, 1, 1, negative 1, negative 7, 2, 8, 2 8s up here. You can see it's going down. Negative 2, negative 8, still going down. Let's try negative 3. So negative 3 squared is 9, plus 4 times negative 3 is negative 12. 9 minus 12 is negative 3. Negative 4 is negative 7. So 3, negative 7. All right, we can kind of see a pattern here. If I do negative 4, negative 4 squared is 16 minus 16, be 0. Take away 4 is negative 4. So 4, negative 4. So you can kind of see, if I can draw this with this tool I'm using, it goes down, it starts to come up. So here is the parabola that graphs that quadratic. That's the end of parts 1, 2, and 3 on quadratics.